Alrighty. So that's the beginning of class time. So we're going to get started. Today, we're going to be covering Chapter 4. Or you will be working on a Chapter 4 tutorial. So hopefully you have your SOLIDWORKS getting started up, getting ready to go. We're going to be using SOLIDWORKS today pretty much every day. So standard operating procedure, you can come in, get started SOLIDWORKS going, be taking notes. I kind of have some introductory statements about the initial design exam. So that's the next step in the process, is you've selected a design and now you're going to start analyzing it. You're going to break it down into its parts. Like I mentioned last class, every independent part should be modeled separately. Even if you can't physically take it apart, it should be modeled separately. I've got some outlines for that. One question that came up, a student had asked if they wrote something in your design selection, are you married to that idea? No. Meaning, I asked you to suggest how you would improve or change the design. You don't. It's not like a declaration. I'm not gonna. When you get to the end of your class, because what did I say about the first design exam? What was something I said about the first design exam?
We're not making any changes.
You're not making any changes. Thank you very much. At least one person's on the same page with me. Hopefully everybody's on the same page. You are just modeling what currently exists. So and I'm going to ask you each design exam, I'm going to ask you to kind of tell me a little bit about how you're going to improve and change design. And I hope that idea will change as you go along. And in fact, it should. You should, while you're modeling these things, you might have ideas and you might say, hey, listen, why is this thing here? You know, why did they model a little piece on the side here? You know, and you learn a little bit more about the design and it may give you ideas as to how you could change it in the future. So I encourage you to remember that you are not married to that. All I'm doing is forcing you, by way of my instruction, to think about how you would make a design change. Getting yourself into that mindset or say, hey, listen, I can make some design changes. You have full agency. You can always change that. So I want you to remember that just because you wrote it, even if you wrote it up in each of the reports and said you're going to do this one thing and you decide once you start making those changes you don't like it, you can certainly change. Now, I will encourage you and say some things, some design ideas I might say, hey, listen, that's a pretty good idea. Or I might say, hey, listen, you may need a little bit more. I'll try to coach you in the right direction. So if you wind up not paying attention to any of my advice and you make something and I grade it poorly because you didn't really go over with me, you know, that's something you should be wary of. So you're certainly always welcome to talk to me about your design ideas and how to change it. That's how we do design. That's how engineers do design in teams. There's very rarely just one person making decisions and making changes. There's always design teams that come together and figure out how to improve or change a design. So the more experience you guys get doing that, the better you'll be when you go off and become engineers on your own. You take flight into the world around you. All right. So that's what we're going to talk about today. We're talking about Chapter 4, talk about the design exam. But before we get into that, do I have any questions? You can unmute yourself and ask, or I'm looking at chat. And I apologize. I'm trying to give due diligence to chat. I know some of you prefer the chat, and I apologize if I don't get to it like right away because I'm trying to get better about looking at chat. So if you want to put your question into chat, please do that. All right. Thumbs up if you're cool with everything. Yeah. Thumbs down if you're not cool with everything. Somebody did a thumbs sideways if you're just meh. Okay. So let's talk a little bit. So I have here, this is a document. It's on D2L, so I'm going to switch over here. Ooh, move that over. So this is D2L here. I have loaded in the content section of the thing, I have one that's called Initial Design Exam Materials. This is one I want you all to go into. The first document is very important. It's the Initial Design Exam Template. So this is what you're going to start with. So I'm going to talk today about technical writing. The slides for today are are in chapter 4 materials, but I also have them kind of reproduce here for technical writing. It may be from a previous semester, so the dates may not be 100% accurate there. But if you want to see the actual slides from today, if you go to chapter 4 materials, these chapter 4 slides have the technical writing inside of them as well. But if you're looking at initial design exam materials here, I have the initial design exam, what's it called? Template. And the way that that looks like, where is it? Let me open that up real quick. So this is the initial design exam, and if you look, you can see it says last name, first initial. That's because you're going to replace that with your last name, first initial, and then you're going to have initial design exam, okay? You're going to come through and you're going to replace everything, pretty much everything except the titles, so you can leave introduction and so on and so forth. And we'll talk about each of these sections in the slides in the class material. But you're going to replace everything here except for this writing here, right? You can say leave initial writing exam. This needs a change here. This is my mistake. I'll update that. This is not EGR 210. And you may see errors like that in the future, but that's okay. But obviously, what do you think I want to have right here?
Picture of the design.
Thank you very much. You think it's funny. You may be laughing. But I've gotten students that submit this and they just leave this in here. And I'm like, no, replace this, okay? Same thing goes for this. If I see any of this, somebody's going to do it. One person out of the group is going to do this. And I say this before, but don't be that person, okay? Now, you don't have to delete it right away. You know, I encourage you to read this. I'm not going to read over it. You can read it for you. But I kind of encourage you or talk a little bit about what I'm looking for in each of these sections here. Okay, I give some information about the types of formatting I expect to see, but here is the introduction. And then there is the background, and I talk a little bit about what's required for the background, procedure, results, conclusions, and recommendations. And then lastly, references. Okay, this is your first design exam, and it's due when?
2nd.
October 2nd, good. So those of you who are looking closely, this is due October 2nd, 2020. It's going to be at 5 p.m. October 2nd, 2020. So we got us some time. Right now, what you should be doing, even before you download this template, is you should be making your parts. And hopefully you've got one part made today, and we'll take a look at those a little bit later. But this is the document. Make sure you download that. I also have IEEE citation reference. This is, if you're wondering how to format your references, this is how I'm going to grade yours. I also have the initial design exam grading rubric. So how am I going to grade your exams? If you want 100% on these exams, this is what you need to look at. You need to read through and look at, well, how am I going to grade introduction, background, procedure, results? How am I going to grade your CAD model, your CAD model submission? Okay, this is how I'm going to grade your design exam. This is the rubric for that. So I'm laying it all on the line here so you can see how we go through. And I also have bill of materials format. We'll talk a little bit about the bill of materials. And then lastly, we have the slides that we're going to go through momentarily. But I've opened up this. I've also opened up the chapter 4 materials. And so that's where you can find the slides for today. I also have videos for the tutorials you'll be working on this week. So you will have videos for that. I do not have the scanned copy of the text, so hopefully you have the textbook now at this time. Please make sure to read through that and go through the tutorials. All right. Do I have any other questions on that before we get into technical writing? Chat, good? Everybody good? Good. Okay.
Hey,
yes.
You got anything, anything else about us downloading SolidWorks?
No, that's a very good question. So we're still waiting. So we've paid for the format. So you should have it. I'm trying to get information from them. In fact, thank you for bringing that up, Kurtrick. I will have an answer for you by Thursday. So next class, I'll put together a small thing or send you guys. If I need to, I'll send you an email with instructions on how to install SolidWorks onto your own machine. That's a very good question. For right now, please stick with the VM. And
It's such a hassle.
Huh?
It's such a hassle.
I apologize for that, and I know it's we're trying to fix that, but that should be something that's coming along shortly. Thank you for bringing that up. That's funny because I sent him an email. I haven't heard back, and it's just been kind of in the back burner for me. But I will send another email. Okay. Do I have any other questions? That was good. Thank you. trying to encourage with my behavior. Lincoln and Christian, what are you guys doing? Come on now. I see you guys. This is why I want the camera on.
Background. We're just curious.
Okay. All right. So today, what I wanted to talk a little bit about is what we're going to be covering, right? You're going to be in chapter 4. We're going to deal with really primarily 2 of the other ways of creating major features. A loft, which is this thing right here. You're going to do an exercise. We're going to make a business card holder and then a sweep. Okay. So all these things here. Okay. That's a sweep. I think sweeps are way more useful than lofts. Lofts are okay, especially if you're making like 3D printed parts and stuff, but it's very hard to dimension. And so I encourage you, if you have situations where you think you just need a sweep, I would like to talk to you about that. Sweeps are good for, they have their uses. And if there's a part in your design you feel that it has to be a sweep, I'm sorry, not a sweep, a loft. It has to be a loft, my bad. I like sweeps. I don't like lofts as much. Right, this is your loft, and this is your sweep. Okay, if you feel like you need to use a loft, let me know, and I'll be surprised. But I like sweeps a lot more. In fact, I think if you guys have any geometry, usually that has to do with like a frame. I always think of like a frame of a bicycle or something. Sweeps are really good for that. I don't think anybody's here doing a bicycle. But you may have a structure to your design that maybe a sweep would actually really be helpful. So hopefully when you're started designing your part, you can always go back and remake your part, maybe using a different method or different style. And I promise you, even if it took you a long time to make that first part, every time you recreate it or go back and revisit it, it gets a little bit easier. And so hopefully you're starting to see that now. But we're going to talk about that a little bit later. Let's look at where we are in terms of the course calendar. So right now we're at week 4. And we're semi on track. We're pretty on track from where we expected to be. We're on chapter 4 material, even with the setback with the hurricane and whatnot. And of course, right here, as we had said, is the initial design exam. That's due October the 2nd. And so that's fastly approaching. Okay, that's a Friday. So what do we have? Like 3 weeks? Not even 2.5 weeks, something like that. So the sooner and I'm going to be asking every day, I'm going to ask for a little bit more because we want to push a little bit. We want to create your exam as we go along. And remember, nothing new. You're only going to be modeling what currently exists. Okay, and then we're gonna get into next week. We're gonna talk a little bit about parametric modeling, and then eventually we're gonna get to assemblies. Okay, so week 6 we'll get into assemblies. So up until that point, weeks 4 and 5, we're still going to be doing part modeling, and so that all should be material you would use while making your parts for the first design exam. Okay, homework for chapter 4. That's set up. It's due Friday, the 25th of September. And those are the problems. Of course, go to D2L and download the Word document. There's a template that's on the chapter 4 material. So make sure to download that as you have been doing. And we'll get that graded as soon as we get that in. Okay. Other than that, that should be it for introducing chapter 4. Let's take a step back and talk a little bit about technical writing. Technical writing is one of those things where you're probably going to get a lot of experience as, developing engineers going through. When we have ABET. You guys know what ABET is, right? What's ABET stand for?
Accredited Board of Engineers or something like that.
You're 75% of the way there. Accreditation Board for Engineering and Technology.
No.
Good. So ABET, otherwise known as Accreditation Board for Engineering and Technology, they kind of dictate the quality of degree you're getting, and we are accredited. We have an accredited we are accredited program for engineering. So if you're taking your engineering physics degree, or you're taking this class to supplement to another engineering degree, it is part of an accredited program. One of the things that we use down from ABET is we have a lot of employers that look at our program and say, these are the skills we want your students to have, because they're the ones that are going to be hiring you. Okay. One of the skills that engineers are notoriously mediocre in is creating a good set of technical writing. Okay. It's something, the more practice you get, the better you'll get at it. So please view this as that. Okay. There's no formal exams where you're sitting down, you're writing out questions. Everything you're submitting in terms of exams are going to be part of technical writing, and I kind of want to set up the guidelines. And how do you do well? Well, you got to pay attention to the format as well as how your writing will look when I'm reading it. Okay, and the easier it is for me to read it, the better grade you get. That's how it works. Okay, so one of the things I kind of bring up early on is we want you to. The number one thing here is to be clear. Okay, and what I mean here is concise. Right. So be as concise as possible without losing meaning. A good scientific document or technical document is one where I could go through and not be able to take out any words without losing some meaning in the statements. So the way that my advisor, when I was learning how to do technical write, he said avoid flowery language. I remember him saying that, which is funny because the word flowery is kind of flowery language, is it not? So he always kind of and so you want to stay away from those adjectives, even though you might be used to doing that maybe from high school or whatever. You want to be as dry as possible when it comes to this. You want to be dry, clear cut, so there's no opening for misinterpretation. Okay, make sure the finished copy flows logically towards a conclusion. The way that I read this, or the way I'm telling what I'm saying here, is when you get done, when you finally write your final report, read through it one last time. Okay. The way I write a technical document, the way that any scientist, self-respecting scientist would write a technical document or a paper or whatever, they write it in, they'll write some of the conclusions first maybe, and then they'll go and write the introduction, and then they'll maybe they've got the procedure written already, and then they've got the results set written. It's all disjointed, and that's completely fine. Now, it's very rare that you would write a whole thing from the very beginning going down to the very end and then coming back and edit later. A lot of times you're piecing things together. At the very end, at least read it through, because it's going to have a logical progression in terms of where you're putting certain materials in. I have a real quick statement. If you use the template, you shouldn't have any problem with this. Make sure you get the font sizing correct. Make sure that all your verbs are past tense, and you make sure they're consistent throughout. The reason why, what this really means is you're reporting on work that's already taken place. There is a small portion where you may talk about future work, and that's when you can use the other tense of verbs. But typically you don't say, for instance, you would say a model was created, not we're going to create a model. Okay, you always use the verbiage to say that the stuff has already been done. Okay, even though maybe while you're writing this, it hasn't necessarily been done, but by the time you submit it, that should mean that it's already been done. Make sure that any terms, symbols, or acronyms are defined at some point in the paper, especially if they're unfamiliar to the reader. For instance, you may want to go into what CAE represents, okay, if you're using that in the main body of your report. You need to make sure you present facts or inferences rather than personal feelings, okay? Something I get a lot is when people are, especially in this class, when people are describing designs. Okay, you guys are very colorful when it comes to making or statements about your designs. You use the terminology like this. You usually a lot of times, and I think this is my way of getting you into thinking of design, is that you want to try to sell it to me like the design you currently have is garbage, and you are going to make it amazing. Okay, and you kind of say that, you say things like, oh, this thing always breaks, right? Or I always, you say it always falls out of this, or it never works as intended. Avoid those statements because they're really just your feelings, okay? Most of the parts that you guys selected work pretty well. Otherwise, you probably would not have bought it or continued to have it, with some few exceptions. Don't write about it. Write your inference. So here comes that word inference. We talked a little bit about it. Didn't I ask you what I meant by an inference, an inferred thing? What did you guys call it? A guess? From a scientific standpoint, an inference really, when you're writing a technical report, you're putting something new out there. Whether it be you're modeling this new thing, or you're writing on how you're going to split the atom, or you're going to write about some experiment you're doing before. You're putting new knowledge out there. And your inference is it's what you are adding to the story. So maybe you have observed that your particular design, it fails in certain conditions. You can say that, but stay away from feelings like I always see it. It's some people that they talk about their design. They say avoid saying things like it always messes up or you can never get it to work right. Avoid saying those things. What you would rather want to say is sometimes it fails, which is an inference that you have made through your experiences. Okay, try to maintain a professional tone. So don't use facetious or emotional type statements. Things like jokes, not a very good place for jokes. Even though I try to make jokes in class, this is obviously not a technical, I'm trying to give it some color because otherwise you guys are just bored. Maybe you're still bored. I don't know. But anyways, in a technical report, you want to avoid jokes of any kind. My biggest threat here is that if your boss, your boss really well and you can put some jokes in the technical document, but maybe that document makes its way to their boss and their boss has zero sense of humor and they see this document and they kind of reflect poorly on you. The big thing I see with presentations, and I've seen this at national conferences, where people will put, like, you guys ever been to a talk and the very last slide where they're asking for questions? I remember there's one time this guy had like Darth Vader or something and it played a song for the questions part at the end and it went over terribly. Like when this person did that, I'm sure when they were making their presentation that it was funny to them, but nobody it was crickets. And it set a very poor tone. And you really want to avoid that kind of stuff when it comes to technical writing. So please stay away from sarcasm, memes, okay? We don't need them here. Just be clear down to the facts. One thing this is a big thing right here, and I expand on this, is I need you to number and caption all tables and figures in your document, all right? If you have not done this yet, if you've never done it, if you don't have any idea what I'm talking about, this is something I'm going to grade very harshly. If I see that you do not number and caption all of your images, figures, okay, or your tables, you're getting points taken off. Okay, I'm gonna it's bad. Okay, you guys need to know whenever you put a picture or a table in your report, you have to have some reference to it. And what do those look like? Well, I've got some examples here. Okay, so. If I have, this is a picture of my model. So today you're going to be making, today you're going to be making a business card holder, but on Thursday you're going to be making these handlebars. Okay. If you're showing this, you need to make sure that there's text below this that labels it as a figure, right? In this case, this is figure 1, and it has some description of that particular figure. This is a very general case here. And then what will happen is you're going to actually, in the main body of the text, you're going to refer to that figure. And that's very important. So every picture you put in for your results section, you're gonna have. I've seen students have 100 figures in their design exams because they have that many parts that they want to show off. Okay, doesn't matter. They each need to be referenced in the main body of the report. Lastly, secondly, tables also have a caption, and they are numbered separately. So these two could be in the same report, right? Tables and figures are numbered separately. So you can have a table 1 and a figure 1. They're treated separately. The big difference here is that figures are captioned below the image and tables are captured above the table. That's a big difference here. And then everybody's going to have this right here. Everybody's going to have a table for bill of materials of their design. And so if you're taking notes here, this is very important. Okay, I'm assuming Lincoln is taking notes. Is that what he's doing? There we go. He looked at me. Okay, good. That's how I test you. But everybody needs bill of materials for their design. And the things I'm going to look for, you're going to have a part number. Okay? You're going to have description. You're going to have the type of material. You're going to have the finish. And you're going to have how many of those parts exist in your design. Everybody's going to have this. And I want everybody's table to look the same. The reason why I want that to look the same or the way I'm going to get it to look the same is we're going to use a template. And okay, so that's where we have, excuse me, that's where we have, on the initial design exam, there is a bill of materials format. Okay, and so if I download this and I open it up and I move it over so you can see it, okay, this is what you're going to see when you download the bill of materials. Now, obviously, you're going to have to replace this. And each of your parts need to be numbered. So when you're saving your parts for your design, you need to number them. It's always, and so this is something you should be doing right now. So you may have made other parts for your design. That's okay. You just have to go back and rename them. and you're going to have to name them their part number. Okay, so we want to start thinking about your parts as a part number. Now, Dr. All, which one's going to be part number 1? Which one's going to be part number 2? I don't care, as long as you're consistent. And so that's where the description comes into play. So for instance, this I believe is from the staple remover example we had where I showed last class. And I show here is part 1. I say that's the grip. Part 2 is so on and so forth. Okay. You can now use a description that is clever, or I'm sorry, is clear to you and potentially me, so that you can always come back and refer to it. But you should be start referring to it by a part number. Now, these are very simplistic because I don't think anybody's going to have over 1,000 parts. So you can just use 0. And I encourage you to say, call it part 001 rather than just part 1. I'm also wanting you to look at the type of material that each of the parts you're working with and kind of figure out, is it, I say it's resin, okay? Because I think the grip for this is some type of resin, but maybe you call it a composite or you just say plastic. That's fine. Here, these are steels. And if you have a question, is it a steel? Is it aluminum? Is it nickel? Come ask me and I can help you I can point you in the right direction. And maybe you can look at other ways to maybe determine what type of material it might be. I also talk about a finish. For instance, the resin I think is dyed brown. And then the metal, the steel parts were chrome plated. Okay. Yours may not be as clear. Maybe it's unfinished. So I might see a lot of unfinished types of material. That's completely fine. Okay. I'm looking for some level of assessment here. So you should be looking at your design and think about it. If you were an engineer, the idea is your bill of materials would be you hand it over to your finance department or your purchasing department, and they would get you all of these materials. Okay. Maybe they'll get you a different, if you don't specify which type of steel, they're just going to get you any old steel or the cheapest steel they can get. And that's okay for this process. But this template here is what I want you to use for your report. And the way you would put it into your report is very easy, especially if you're using Microsoft Word. So if I've got this is my report template here, and I say, for instance, the bill of materials is going to go in the background section. I believe that's where your bill of materials is going to be, right? It says bill of materials here. If I want to put this into my bill of materials, I can make sure I've got a space there. I select this whole thing, Control C. All I did is press Control C, and then I came over here, Control V, okay? And you can see it popped up over here. And that's okay, right? That's all you need to do. I see so many people that take like pictures of the table for some reason and put them in here. You don't have to do that. Microsoft Word and Microsoft Excel play very well together. And you can come in here and make changes. So, I can do that. Okay. I'm going to close this so you don't have to save those. Okay. But anyways, so make sure you get your bill of materials format from there. Any questions on that? Okay. So make sure you number and caption all your figures and you refer to them inside the body of the text. What do I mean by that? Alex, what do I mean by referring to your figures inside the body of the text? Can you unmute yourself?
When you're talking about that part, just put the number in there.
Where?
In your text.
Yeah. So while you're writing about it, right, you're going to say in figure 1, this is the handlebar. You'll talk about the handlebar. You cannot just have a figure in there, figure 23, and whatever it may be, and it not referred to in the main body of the text. Okay. These figures are meant to supplement what you're writing about. Okay. So here's where I talk a little bit about the major sections of a technical paper. And we're going to be using these. And I'm sure you've written lab reports in the past, and you may write other types of technical papers out there, and they may all look a little different. But in general, they have these kind of 5 major sections. There's always going to be some form of introduction. And past that, you might have what's called an abstract. How many people have written abstracts before, at least in some capacity? A few people. How many people have never heard the word abstract for a technical paper before? One person, okay. An abstract, what that's meant to be is it's meant to kind of go over, it's a very short, typically 200 to 500 word almost an overview for your type of paper. It's used a lot in scientific communities because you may read an abstract and get a flavor for what the paper is going to do. I always consider an abstract should have all the salient details. Like, for instance, if you are taking measurements and you have a specific outcome, and you say, for instance,
no.
What's that?
Oh, yeah.
Hello?
There we go.
You had a stroke again.
Oh,
yeah,
no.
you're good.
Sorry about that. My internet has been a little buggy, so I apologize if that comes out. I sometimes can hear you, but maybe not you can hear me. And I also am recording this, so I should have a full copy of it little later on. But anyways, I was getting at an abstract is really just a kind of a short statement about your paper. I'm not requiring it for this paper, but I am requiring some introduction. And it's meant to overview the entire report. A brief statement of how your end design can be improved. So it's going to talk a little bit of how you're going to analyze the part, how you're going to go forward. Okay. You're going to have a background section that's going to give a detailed overview of all the design functions of your design. That's where your bill of materials is going to live. And you're going to talk about each of the parts in your current design. Your procedure is going to be how you created your parts. This is where you're going to talk about SolidWorks. Maybe you use some interesting features and show kind of the method for modeling. What I'm not looking for here is a step-by-step instruction on how you modeled every single part. I once had a student that did that. That is not what I'm looking for. What I'm looking for is a description of some of the features you used to model your parts. Think of it as like an advertisement. You're trying to advertise to your boss how cool you are for using a combination of extrudes and revolves, maybe even a sweep, and then talk about those tools. That's the idea of this procedure section. So pick out kind of a cool part or a cool portion of your design and talk about it there. And then lastly, or semi-lastly, would be the results. This is where you're going to show the CAD model for every part listed in the bill of materials. So that's in this design, the first design exam, you're going to have every single CAD model that you work on is going to be in the results section, and you're going to talk about it. Another mistake I see some students make is they just submit to me a results section, and it's all just pictures. That's not what I'm looking for. I want you to talk about those results. Talk about each of the parts.
Oh, there it goes again.
Epi's gone.
Hello?
Yeah, he's going again.
Hello?
Poor Dr. All.
Can you hear me?
Clearly, I'm not the only one with internet issues.
Hello?
Welcome
go.
back again.
Sorry about that. I can hear you guys during that portion, but I apologize. So I'm going to, since this is messing up for me, I'm going to kind of go through these things. One last thing, you need to have conclusions, recommendations, where you're summarizing and then talk a little bit of how you're going to modify your design later. And then references. Very important that you're going to have at least, how many references do I say here? I think at least one. What do I say? I need to make sure I get this correct. Design exam, grading rubric.
He's gone again. Right in the middle of his thinking. Yeah. Or maybe he's just thinking really hard.
Can you guys hear me?
Yeah.
Oh, there you go.
I don't know what's happening. If it's my computer or what, but
Could be Zoom.
Who knows? Okay, probably could be Zoom. Yeah.
it's probably me. For right now, make sure you get at least 3 references. Target 3 references for your design. Okay. One of those can be the textbook that you're working with, so you can go through and reference that. The other can be maybe the manufacturer for your particular design. You can reference them in some way.
I could email them and ask them for blueprints.
Maybe if you get that, I can't fault you for that. One of the last things I kind of want to say for a technical writing, do not use things like I or we in your report. You're always going to use something kind of in the what's it called? You're saying like something else, somebody else has done it before. And I've got 2 examples here. So rather than saying I took measurements of my design with a magnetic caliper, you would say measurements were taken with a magnetic caliper. Okay. So it's a slight subtle difference there. You're just taking yourself out of it. You should never refer to yourself kind of in the body of the report. Just say that it was done in some way. Some another example here is you'd say something like, I think the union in figure 3 is used to support incidental sideloading. That's an inference. So take that I think out of it. So you just say the union in figure 3 is designed to support incidental sideloading. So these are just some examples. So you should be able to, and if you ever run into issues of trying to remove yourself, because I will literally, when you submit these, I want to search for I and we, or me, and see if there's any instances in the exam that says that. So if you're running into issues of trying to write and take yourself out of it, just let me know and we can kind of go forward. So I've also got some references for how you would put numbers into the main body of the report so you can follow through with that. And let's get to, before my internet cuts out, let's get to the main meat and potatoes for your activity today. You are going to create a loft. And so if I haven't described it enough, I don't like lofts too much, only because they're very hard to define. They're going to create an interesting geometry, and they look kind of cool. The idea of it, am I back? Am I still here?
You never left this time.
Okay,
man.
great. I'm worried. I'm gun shy now. The way a loft kind of works is you're going to create two sketches. This is one sketch up on top and then one sketch on bottom. And SolidWorks is going to stitch those together. Okay, it's going to go from one side to another, and it's going to try its best to format around that side. Okay. Think of it as kind of like a guided extrude, kind of weird and wacky way. The reason why I don't really like these too much, especially for your drawings, when you're making drawings of your parts, is it's kind of hard to dimension what's happening in between these two drawings. And you'll go through this process and you'll see what that looks like. And it kind of makes some cool shapes. I'll say that. Whenever you go from a square shape to a circular shape, it's going to have to absorb these edges here into the shape itself. So it does this by way of what we call a guide curve. And so the guide curve kind of gives this algorithm that SolidWorks uses to go from one shape to the next, and it kind of gives it a way to go through. And so sometimes putting that guide, you can actually set up a separate profile for the guide curve to make it look more interesting. But by and large, they're cool if you can 3D print something, but it's very hard if you're trying to machine this in conventional machining methods. The other tool you're going to use, I would say this tool right here is probably more helpful for many of you in many of your designs. Okay, it's the shell tool, and what that does is it takes a solid object and it will remove the material inside of that, as well as remove a face. So, for instance, this particular design, you're going to use the shell tool to create the kind of you're going to take out material from the bottom of this body here to kind of give it shape, and it's going to be reminiscent of some of those maybe parts that you've used that are kind of built in an injection molded type method, right? So a shell command is going to be very helpful for a lot of different things. And so I encourage you to try to use that, and you get some work with it today when making this business card holder. So the in-class exercise for today is I'm going to ask you to go through section 4.1 in the text. It's going over lofts and shells. And instead of, I think it asks you to change the appearance, I want you to choose your favorite color when you're doing this. So you can choose some other color. So I want to see different colors from everybody. And I want you to make it transparent. I think they show you how to do that. So you're going to make it transparent and make it your favorite color. And instead of part number, you're going to put your name on the bottom. So that's going to be how you're going to change this design. So make sure to write this down, write these two elements down. That's what I'm going to be looking for this in-class activity. And so you're going to start working on that today. That's it for today's lecture portion. We're going to spread out to breakout rooms. And what I'm going to try this time is I'm going to put probably 2, maybe 3 people in a breakout room. So when I come and ask questions, I can address multiple people. I think there are some issues with trying to get through to people. So you might be in a room or whatever with somebody else. And if you have any questions, maybe try to ask your other partner or whatever. But we're going to come through and take a look at your work, and you're going to share your screen. But is that okay? Can I put everybody in groups? Is that a thumbs up if you think that's okay? Thumbs down if you think you don't want to do that. Okay. Some people are about it. We're going to try it. If it doesn't work out, send me an email and say, hey, listen, Dr. I don't really like that. And we won't have to do it again. But I'm going to try to do this so we can try to attack. I can get to everybody because it's tough to get through to everybody. And then, of course, if you have a question, you can use the command to give me a question. Do I have any questions now before we get into the rooms? Yeah, Savon, I'll try to get you both in there. You're probably going to get dragged separately, and I'll just assign you after it creates the random distribution. I'll just assign your 2 instances of yourself into the same room. All right. Any other questions? Okay. And then Ely, go ahead and stick around for a second. I want to talk to you a bit before we get into that.